Now, I would solve problem number 1.39 now. Point moves along arc of a circle of radius r. The arc of a circle of radius r, a particle is moving along it. Its velocity depends on distance covered. Its velocity depends on distance covered, and it's given like this, where a is a constant. Find the angle alpha between vector of total acceleration and vector of velocity as a function of s. Now, total acceleration और velocity vector के बीच में एंगल पूछा है. सबसे पहले, if this is the velocity, this tangential velocity, I'll say tangential acceleration is dv by dt, or this is dv by ds into ds by dt. मैं dv by ds इधर से लिख सकता हूं. This is dv by ds is a by 2 root s into ds by dt is velocity. So this becomes a by 2 root s into a root s, root s would get cancelled. So this is a square by 2. This gives me tangential acceleration, and its magnitude is a square by 2. Then radial acceleration at any point, या तो tangential acceleration हुआ, which is along this. Let me indicate it by a color. This is tangential acceleration. Along with this, we have got a radial acceleration. This is tangential and this is radial. And that radial acceleration is v square by r. v square की जगह पर मैं यह लिखता हूं a square s upon r. This is radial acceleration. And this is net acceleration vector. This is a net acceleration vector. Now they had asked what is the angle between velocity vector and net acceleration vector. So this is that angle that they had asked for. This is a velocity vector. Alpha is angle between velocity vector and acceleration vector, or you can also say alpha is angle between tangential acceleration and the acceleration vector. In order to write this, I will say this tan alpha would be equal to radial acceleration upon tangential acceleration. रेडियल एक्सीलरेशन के लिए लिखता हूं मैं a स्क्वायर s बाय r, और टेंजेंशियल एक्सीलरेशन के लिए मैं लिखता हूं a स्क्वायर बाय 2. सो a स्क्वायर टर्म गेट कैंसल्ड, सो दिस बिकम्स 2s अपॉन r. सो द फाइनल आंसर इज tan अल्फा इज इक्वल टू 2s upon r, or alpha is tan inverse of 2s by r. This is angle between net acceleration vector and the velocity vector. The same is angle between tangential acceleration and the total acceleration. बड़े ध्यान से देखें इसको. so that the rotation angle varies with time like this. This is rotation angle and it varies with time like this. Phi is equal to 80 square, where A is given, A is 0.2 radian per second square. Find total acceleration W of point A on the rim at time t equal to t naught, that is 2.5 seconds. The linear velocity of point A, V is equal to V naught, that is 0.65 meter per second. Total acceleration we need to determine. Now, first of all, I will say, if this is angular displacement, angular velocity is d phi by dt, and this is 2a into t. And angular acceleration is d omega by dt, and that is 2a. For this body which is rotating about this point O at any point P which may be at distance r, we will have two acceleration. One would be tangential, like this. This tangential acceleration is beta into r. Here r is the radius. Or this tangential acceleration is, for beta I will write 2a into r. We do not know the radius, we can determine it. इन लोगों ने क्या रखा है, velocity is omega into r, or this velocity is omega is given to us, that is 2a t into r. And we know that velocity is v naught when time is t naught. So r is v naught by 2a t naught. This is the radius of that particle. Now what I will say is radial acceleration, expression for radial acceleration. This is radial acceleration. Radial acceleration is given by omega square r. Omega is this. So this radial acceleration is 4a square t square into r. This is tangential acceleration and this is radial acceleration. The net acceleration of particle is the vector sum of the two. So this net acceleration is under root of radial acceleration square plus tangential acceleration square. So I will say the net acceleration is under root of radial acceleration square is 16 a to the power 4 t to the power 4 into r square plus 4 a square r square. This is the net acceleration, and I will write it like this. This is 4 or 2a into r under root of 4 a square t square plus 1. And for r I will write its value 2a into, for r I will write v naught by 2a into t naught under root of 4a square t square plus 1. 2a and 2a would get cancelled. and net acceleration at this point is v naught by t naught upon under root of 4a square t square plus 1. This is the acceleration. You can substitute the values. 0.65 upon for time, 2.5 under root of 4 for a, 0.2 and for time 2.5, 0.2 square, 2.5 square plus 1 and get the answer. देखिए एंगुलर डिस्प्लेसमेंट से एंगुलर वेलोसिटी, एंगुलर वेलोसिटी से एंगुलर एक्सीलरेशन. एंगुलर एक्सीलरेशन से हमने निकाल लिया टेंजेंशियल एक्सीलरेशन और रेडियल एक्सीलरेशन एंगुलर वेलोसिटी से ओमेगा स्क्वायर आर. फिर हमने वेलोसिटी एक कंडीशन पर दी हुई है किसी टाइप पर, तो वेलोसिटी इक्वल टू ओमेगा आर, उससे हमने पार्टिकल का रेडियस, और नेट एक्सीलरेशन के लिए हमने स्क्वायर ऑफ रेडियल प्लस टेंजेंशियल एक्सीलरेशन, और इस तरह से यह है एक्सप्रेशन. प्लीज नोट इट डाउन.